Hi, we are in our final lesson of Activity 5, which is 5.3, multiplying polynomials. So far we have been multiplying binomials times binomials and looking for special products and using FOIL. And so this lesson kind of takes us to a bit of a challenge. We're going to start working with some bigger products like binomials times trinomials, maybe even multiplying 3 binomials together. So some different examples of polynomial multiplication. So for our learning targets, we're going to start by using a graphic organizer to multiply polynomials. So we'll use the box method again for a bigger polynomial multiplication problem. And then we'll just go in and show how we're just going to continuously use distributive property to multiply the polynomials together. So a graphic organizer can be used like the one we see here. So for the polynomial x plus 2 times x squared plus 2x plus 3, it's actually 2 terms times 3 terms. And so for that, the box method would have to be 2 by 3 then. So we put the x plus 2 on the top and the x squared plus 2x plus 3 on the side. And then you just do your multiplication. There's where x third to the third came from. X squared times 2 became 2x squared, and so on. And when you're done with that, you will have some like terms that you can combine. So like I see those two get combined and they made the 4x squared. Okay, but I also see another set of like terms and they made the 7x. And then you've got your kind of singletons that are, you know, just your x to the third and your 6. Okay, so the box method is nice and I figured we could practice one of those. And so let's do the one from problem number 1 where we have x minus 3 and then, whoops, and we have, let's see, let's go ahead and highlight. There we go. X minus 3 times the trinomial of x squared plus 5x plus 6. All right, so we'll go ahead and make a box on the side here for problem number 1. And we will start with, so we're going to have a box, more of like a rectangle this time instead of a square. And so we're going to need 2 columns and 3 rows. And so what we're going to do is put the binomial across the top. So we're going to have the x minus 3. And then we're going to put the trinomial on the side. So we're going to have x squared plus 5x and plus 6. And now we'll just do a little cross multiplication. So we got x squared times x. That's going to get us x to the third. And then x squared times the negative 3, which is negative 3x squared. Okay, now we'll switch to the 5x. 5x times x, 5x squared, 5x times negative 3, negative 15x, 6 times x is 6x, 6 times negative 3, negative 18. And then we go searching for like terms. So I see some x squared terms that line up, and I also see x terms that line up. So we'll want to combine those. Okay, so for question number 1, looks like we got our answer. I can see I have an x to the third, and then I have 5x minus 3x squared, so that's going to be 2x squared. I have negative 15x plus 6x is negative 9x, and then I have that negative 18. So we were able to do a binomial times a trinomial, and it's pretty organized in the box. Okay, so that's one way to do it. Okay, now question number 2, wow, look at this. We have got a 4-termed polynomial, and we're going to be multiplying it by a 5-term polynomial. Do we really want to use a graphic organizer for that one? I'm not sure, because how many boxes would we need? We would need 4 across the top and 5 across the bottom. So we would actually need 4 by 5, and we would actually need 20 boxes. So I'm not sure that I would do it that way, but you could. So when we get down to the next set, but this is the first time they really start talking about distributive property, even though you've been using it for years. The idea for distributive property is to make sure you distribute to all the terms in the polynomial. And so for 3a, it's just a monomial times a binomial. So that's pretty easy. X times x, x squared, and then x times 5, 5x. Done. And we've already done problems like B, where we call it FOIL, but it is really distributive property. We go first times the first and we get x squared. And then we do the outers, x times 6, 6x. And then you do your inners, negative 3 times x, negative 3x. And some people can do that in their head. They just do 6x, take away 3x. And then negative 3 times 6, negative 18. We've got to always combine our middles. So we get x squared. We get plus 3x minus 18. So those are both examples of distributive property, even though we kind of call part B more like FOIL. But we are distributing, that's what's happening. So when we get to C and D, these problems, I really don't have enough room on here to show you. So I'm going to switch to Notability so that I can make some good notes for you and show your steps. So if you want to switch to your own paper at this point, that might be a good idea as well. So if I back out of here and I start a new note, and I'll do some paper, we'll do that. Okay, and now what we're going to do is we'll do part C. Okay, so in part C, I'll just keep it blue. In part C, we have x plus 7 being multiplied by 3x squared minus x minus 1. So you have a binomial times a trinomial. And I'm not going to make a box, you can, but I'm going to do this one with just showing you distributive property. So the first thing I want to do is distribute the x to everybody. So I'm going to go x times 3x squared, which is going to be 3x to the third. You remember to add the powers. And then I have to do x times negative x squared. And finally, x times negative 1, negative x. So there's our first 3 terms. Okay. What we're going to do next is distribute the 7. Okay, so if I do the 7, I use a different color, use purple for that. 7 times 3x squared is 21x squared. So I usually like to write that right under the other x squared so they're lined up nicely. And then 7 times negative x, negative 7x. They're lined up nicely. And finally, 7 times negative 1, negative 7. So it's like when you're in the box, you can see those, you highlight those like terms. Well, you can see that you're also going to get those like terms using distributive property. And if you line them up, it makes it easy to combine. So 3x to the third would have been a loner in the box. But now we would have like terms of negative x plus 21x. So that's going to make 20x squared. Oops, that was also supposed to be a square. And then negative x plus our negative 7x is going to make negative 8x. And then finally you would have a negative 7 in a box by itself with no like terms. Okay, so I'm going to go ahead and we'll work on part D together as well. You can get one more example of that. So in part D, we are going to have 3x minus 7 is going to be our binomial. And our trinomial is 4x squared plus 4x minus 3. And we will start with our distributive property. We're going to take the 3x times everybody. So 3x times 4x squared becomes 12x to the third. And then 3x times 4x, well, that's going to be 12x squared. Then 3x times negative 3 is going to be negative 9x. Oops, sorry about that, negative 9x. Okay, and now we'll do the ones underneath. And so if we go underneath, we use the negative 7. So kind of be careful with your negative 7. Make sure you distribute the negative. So that's going to be negative 28x squared. So I'm going to put it under 12x squared. And then I'll get negative 28x under the 9x. And finally, positive 21. And so now we can add our like terms and they're all lined up. So I have 12x to the third. And then if I take and combine the 12x squared with the minus 28x squared, I'm going to get negative 16x squared. Negative 9x and negative 28x will make negative 37x and plus 21. So the binomial times the trinomial tends to give us a 4-term polynomial for an answer. Okay, so I'm going to jump a little bit and I'm going to go to number 8 because I want to show you how to do a set of 3 binomials together and some strategies for working with 3 binomials. So let's start with, let's look at 8a. Okay, so I'm going to stay here showing my work, but I'm just telling you where we're going in the lesson. Okay, so we're going to go to 8a. So if you have to multiply 3 binomials together, so something like x minus 2 times x plus 1 times 2x plus 2, okay? You're just going to want to pick 2 to do together to start, and then you want to do the third one after. So you just do 2 at a time. You can't work all 3 together, okay? So let's say we just focus on the first 2 since they're written right next to each other. And we'll do a quick FOIL. So I'm not going to show quite as many steps because I want us to get quicker at these. So x times x is x squared, okay? And then I do outers plus inners. So it's 1x take away 2x, so 1 minus 2 is negative 1x. And then if I do negative 2 times 1, I get negative 2. Okay, so that's that first product. And now I want to multiply it by the 2x plus 2. Well, I just like to have the binomial written first, so I'm going to do that. 2x plus 2 times our new polynomial that we formed, x squared minus x minus 2. Now I'm going to do my distributive property with the 2x. We'll start with that. So 2x times x squared is 2x to the third. 2x times negative x is negative 2x squared. And 2x times negative 2 is negative 4x. Now I'm going to do the same thing, but I'm going to do it with the positive 2. So 2 times x squared is going to be 2x squared, which I'm going to put under the minus 2x squared. And 2 times negative x is negative 2x. And 2 times negative 2 is negative 4. Now we're going to add all of our terms together, and we will get a final answer of 2x to the third. And in this case, we have actually some terms dropping out. So we got the 2x squared and the negative 2x squared are actually gone. And we'll get negative 4x minus 2x is negative 6x, and minus 4 for our final answer. So here was a case where we did end up with the trinomial answer. Okay. So you've got some practice problems to work on now. If we go back to our lesson, you know you have some practice problems to do. Let's go to those. 13 through 22, and give those a try. And I could do more examples if you need to in class when I see you on Zoom. So don't forget to check your answers, and please let me know if you have any questions. I'm happy to go over them.